In sections 8.3 and 8.4, we're going to be looking at how trigonometry can help us with integration. And in this first section, we're going to look at some trigonometric integrals. These are integrals that contain trig functions, and we're going to use several different trig identities to help us. The first one we're going to focus on here is when we have sine and cosine. Sometimes you might just have one or the other. Sometimes they can be combined. And we're going to primarily focus on a couple identities here. And there's even a table here that can help you depending on whether your sine and or cosine is raised to an even or an odd power. And as the rule of thumb, if we're raised to an odd power, and that's the first two cases, you're going to use the trig identity, and it's inside of here as well. Sine squared plus cosine squared equals 1. If you're raising the sine and or cosine to even powers, and that's both of them even, these two trig identities here at the bottom can be more helpful. And I'm going to do examples using both. To be honest, I think the first two cases might be a little bit more straightforward. Sometimes that third case, you may not see where it's going when you initially look at the problem, so we'll do a few examples of those. But my first example here is where we've got sine cubed x dx. So we've got an odd power, so I'm going to make use of that identity, sine squared plus cosine squared equals 1, but I'm going to slightly rewrite it. And I'm actually use what's here under case 1, where it says sine squared is equal to 1 minus cosine squared. So I'm going to use that down here. So let me scroll down. So I'm going to replace this, instead of sine cubed x dx, I'm going to write it, my pen works, there we go, as sine squared x times sine x dx. So I'm just breaking that apart, and I'm doing that so I can substitute. In place of the sine squared, I'm going to put 1 minus cosine squared. Now I'm going to go ahead and multiply this out. So 1 times sine x, obviously, is just sine x. Then we have minus cosine squared x sine x. We're now ready to integrate. If it's helpful to you, you can write these as two separate integrals. So you can do this. You can integrate sine x dx. And there's a reason I'm going to write the second one the way I'm writing it. Plus here we've got cosine squared x times negative sine x dx. So I'm just moving that negative sign with this, the negative sign, sign, with the sine function. So the first one is very straightforward. When you integrate sine x, you just get negative cosine x. Here, I'm going to do a u substitution. So if u is equal to cosine x, then du is negative sine x dx. And that explains why I put the negative with the sign there. So I've got u squared du. So we have negative cosine x plus 1/3 u cubed, and our constant c added to the end. Now I just need to go back and substitute. Since u is cosine x, we have negative cosine x plus 1/3 cosine cubed x plus c.